Okay, everybody, it's time for the next session. Just a reminder to rate the talks and also ask questions, because you can get scarves for questions. And so let's welcome our next speaker, Tim Flink.
Thank you. Well, my name is Tim Flink, and I'm going to be talking about Upstream First Testing. I guess a little bit about me before as I get started. I work for Red Hat. My job is to test Fedora. So end up on both sides of testing upstream and downstream. So a bit about what I want to talk about today. I want to get into, well, what exactly is this whole idea of upstream first testing? Why should I care? Why should you care? What's available to help people test in Fedora? How can people actually help test Fedora? And leave some time at the end for a conclusion and some questions. So this whole upstream first testing. You can do, as a downstream project, you can do all of the testing and keep it downstream and just look at yourself. For example, in Fedora, if we did all of the GNOME testing and never reported anything upstream, there's nothing stopping us from doing that, but it also seems a bit counterproductive at best. And taking some of the testing upstream, instead of just keeping it to yourself, does have some benefits. Now, the key emphasis here is that it's upstream first, not upstream everything. We tried to, keeping with the example of the relationship between Fedora and GNOME, if we tried to send all of our Anaconda testing upstream, wrong upstream, but either way, it doesn't always make sense, so it's not in everything all the time. And there are always going to be some things which don't make sense to be pushing upstream. But that being said, by the benefits you can get from pushing some of that testing upstream is a better relationship with that upstream project. You can catch important bugs earlier and just in general improve the quality of the upstream, which, if you're depending on it, will trickle down to you eventually. So why should I care? Using an image that I'm sure no one in this room has ever seen before, test all of the things. So, why should I care as a downstream? More testing upstream means things get fixed faster. It means issues get found faster. It means everything starts getting upstream earlier, and is going to mean less work for me as the downstream eventually. So it's faster. It improves my product, and it improves their project. And then as an upstream, why do I care about some upstream first testing? It increases the testing. It increases participation in my project. And more testing means finding more bugs and more fixes. So similar benefits. It's just sometimes the target of those benefit changes, but in general, both groups really do benefit. So getting on to what's available in Fedora to help push some of these tests upstream. The three things that I want to go over is OpenQA, BEAKER, and TASKOTRON. So getting first into OpenQA, there have been several presentations already, and there was a workshop this morning on OpenQA. It's something that came out of OpenSUSE, and it's something that they use very heavily, and we've recently started using in Fedora. That it's being used to test nightly composes and rawhide to make sure that nothing has broken in the last day or so. OpenQA is great for graphical testing. The whole idea of OpenQA is basically take a screenshot, and there is a picture I'm looking for. If I can find that picture, click on it, or click on it and type something, and goes through an entire installation process like that. Another way it was put to me is it's great for tests where you can't go in the back door. There are certain times when you can't modify the thing under test to put in some sort of test interface. The only way to really go at it is to go at it if it was some sort of person. And that's one of the things OpenQA does really well is, The test can be difficult to maintain, but sometimes there's really no other way to do it. And the execution model is, in general, you schedule a job against artifacts. That artifact can be an ISO, that can be a kernel RAM disk pair, but you schedule against that, and you give it a test. That's delegated to the worker. The worker does its work, hence it's being called a worker. And the graphical output from that job running is compared to pre-rendered screenshots. Again, looking at what it's supposed to look like, is there a component in there that I can find that I'm looking for, click on it, go on and go through, and really testing, making sure that what you're getting back is what you expected. So BEAKER. Given the audience, I suspect most people here have heard of BEAKER before. BEAKER is a test automation system and lab management system written, maintained by Red Hat, and it's used very extensively to test RHEL. Fedora does have a BEAKER instance, and that has both virtual machine clients and hardware clients. And it is something that would definitely like to see more use of. BEAKER is great for things that need. Mm-hmm.
Like what lab management system and test automation system in common that is connected in one. I've seen BEAKER, but I don't understand this relation between these two like separate problems.
Mm-hmm. And the question was how there's what the relationship is between lab management and test automation. And the best way I can think of to answer that is once you get to a certain size, well, let me try that. Let me start at a different place. Whenever you involve hardware with automation, it's going to be difficult. Things are going to go wrong. And at some point, you have a pool of hardware that needs to be managed. You need to know how many of them have, which generation of Intel processor, how many of them have, 32 gigs and more of RAM, how many of them have, ARM7 versus ARCH64. So the overlap, I think, is there because you can tell BEAKER, I want to run this job against ARCH64. I want to run this job against a machine that is in a specific lab. I want to run this against, so on and so forth. So by putting the lab management with the test automation, you can match the test that you want to run against a specific piece of hardware that is also being managed by the automation system. Does that answer your question?
Yes, kind of. But I would still expect like two different systems, like two names, BEAKER, one name, something, another name. Like I don't understand this composition.
Then I suspect.
Every project has their own link.
Well, that gets into a whole different issue that, pretty much everyone has their own homegrown automation. I don't know if I have a better answer for you as far as why BEAKER has both of them instead of it split up, because I'm pretty much a consumer of BEAKER, and I'm aware of what it does, but I don't know as much about the backstory of it. But since I'm supposed to be giving these away anyways, thank you for asking. As at least I think I've dodged your question sufficiently, or at least the more pointed parts of it. I hope it was at least some of an answer. I know there are BEAKER folks here you can ask. The guy back there in the blue shirt would be a better person to ask that question of. Blue, green, it's more blue. So it's, I think of a BEAKER as something that is really good for something that needs bare metal. That's one of the things it was really originally designed for, was to give you bare metal hardware with a known setup so you can actually run your test. But that being said, because it generally, when you're using bare metal especially, because it does that install every time, if you have a job that takes 5 minutes, it's kind of weird because you end up with 20 minutes or 30 minutes of setup, and then you run for 5 minutes, grab your results, and then it's done. So you can do it, it just seems a bit odd. So getting into the execution model, for Beaker, you submit a job. A client is allocated to that execution. On the client, the operating system is installed. Either the original way was using Kickstart. There are some ways where you can get like OpenStack clients that have the operating system pre-installed. But then your job is run, logs are collected, and the machine is returned to the general pool. Which is pretty much how it goes through. One of the things that I see about Beaker is that it was not originally designed to be triggered automatically. So one of its main user interfaces is it expects people, expects me to go to the interface and say, all right, I want to run this job against this release of the operating system, and I want this kind of a machine. I'm going to push the button and then come back and look at it later. There are ways you can work with Beaker so that it can go beyond that, but that's one part of its, the way it was designed that it needs to be taken care of, I guess. So getting last to Taskotron. Taskotron is a system, not one single thing. It's something that is written and maintained by my team in Fedora. And the core of that is the libtaskotron runner, which is responsible for most of the guts of it. I have, what is it good for? I have everything with a question mark because I honestly don't believe there is a single automation system out there that is good at everything. But the reason that I kind of have it up there is one of the design things about Taskotron is it's supposed to delegate the specialized stuff off to things that know what they're doing. So if we need to do hardware tests, the idea is to delegate it off to Beaker. If we wanted to do install tests, delegate it off to OpenQA. So that there's less of trying to do everything, and it's more of acknowledging that someone else is going to have that expertise. Some other package of software is going to have that expertise. Let's take advantage of that and just provide them the place to run it and an interface to put the results into so that other people can see what has happened. But similarly, going into an execution model, it's triggered on Fed messages. So basically anything that can create a Fed message in the Fedora infrastructure, be that Koji builds, be it Bodhi updates in different parts of that process, or compose completion triggers, or even other tasks, that can start off something in Taskotron. The way that we have it set up now is it will create a virtual machine so that no matter what happens in that virtual machine, that client is always going to be in the same state for the next person. So you can remove the root file system. You can install whatever you want. You can destroy whatever you want. If you destroy the whole virtual machine, your task may not complete, but it's not going to affect the next person. But once that virtual machine is created, it assumes that every task is going to be its own Git repository so that the person who wrote it can maintain it, just push to Git, and doesn't have to worry about anything beyond that. Clone the repository, execute the task described in the repository, and then take those results and report it to a central database. Again, it's a bit more of an emphasis that it's designed to coordinate those automated tasks, not necessarily know how to run everything in its raw state. Also, it is relatively language agnostic. As much as I like Python, there are people who hate Python. As much as someone else loves, Perl or Ruby or Shell or OCaml. I may not like that, but we don't want to say you have to write everything in Python. So it's relatively language agnostic. As long as whatever is running that task returns something we can understand, be that XUnit XML or we have a YAML format, that we can work with. And it doesn't matter then if you write it in Perl, if you write it in OCaml, if you write it in C. And the runner itself is just a single, is a single SRPM. It's different modular RPMs. you can run it as easily on your local machine as if it were being submitted to the system we have set up. And I just want to emphasize that because I've used systems like that before, where you have to have the server and the client component, and it's two different virtual machines that take 4 hours to set up. That's not what we're trying to do. The idea is to make running it on my local laptop as close to running it into production as we can reasonably make it. So, getting on to, how can I help test Fedora without spaces? Is try to get some of the appropriate, for example, if you're a Red Hat employee and you're working on something that could be appropriate to be released, try and get that released. Talk to management, see if that is something that could happen. Even if that can't, try, help work with upstreams to get things tested, to get your project being tested. Well, that came out wrong. Just working with upstreams. I mean, one of the reasons why we have a Beaker system is because the Beaker folks have helped us put it together, and they're helping us administrate it. And the last thing is a bit of a shameless plug. Come to my automation workshop at 2 o'clock. Be going into much more detail on how to use Taskotron to write automated tasks. All right, so as much as I should know better by this time to not do live demos, I'm going to show off a few things. One example is this. This is a repository that was, or this repository of Beaker tests that was contributed by people who have internet. Is it going to load? Maybe. But these are a subset of the tests that one of the QE teams within Red Hat uses to test Anaconda. So it's an example of, it's not all of the things that they run. It is not the most sophisticated things they run, but it is things that we can use in Fedora that will probably make their lives easier if we find the things, while we're in Anaconda's development cycle, instead of they find it after, RHEL has been forked and that patch has to go back into multiple places. And then just a few examples of the systems. This is OpenQA. This is just one of the last things that we ran. Not a whole lot to say. I'm worried to click on any of these links because things are taking so long to load. Same thing with Beaker. Well, let's see what happens. Be adventurous. Alrighty then. Okay, so instead of that, I'm going to go into, since I had kind of hoped to do a demo, but considering how bad my network connection is right now, let's see, I tried one.
Just to interrupt you, I was talking to somebody I was speaking to, a student at the university, he has no trouble on the university connection, not on our open Wi-Fi. So maybe somebody volunteers to you stand off.
Yes, but I don't have a network port on my laptop. It's with the, I have one, but it's in my hotel room, and I think it's going to take a little long to get over there. I honestly, at this point, I'm kind of thinking this is the standard output from one of the things I was going to try and demo. And like I said, you'd think by now I've done enough presentations I'd know better than to even try doing. Okay. And again, the demo that I was going to try and do, just to kind of demonstrate how this can work well. The idea behind...
This is how Beaker works with Fedora.
Okay?
This is how Beaker works with Fedora.
What do you mean?
Beaker guy.
Yeah. Well, I mean, it's like, and I wouldn't want to take that too far because I actually can't use this. So I hope you weren't trying to make that point. Oh, well, I wasn't. They're generally very helpful. So the idea with this is Taskotron trying to run some shell scripts. This is a test case that was written for Apache HTTPD, and a Fedora contributor wrote some very simple shell scripts that are meant to run against HTTPD. So this is in a very verbose mode, but is this big enough? Can everyone read this, or should I make the font bigger? Okay. So, basic stuff, how, where it's starting from, when it started. So what this is going to do, I suppose is going to go, it downloads, it's triggered on the build of HTTPD, and it goes and it downloads the Koji build. It creates a repository from that. It installs HTTPD and a couple other dependencies needed for the tests. It runs through those tests and then reports that back to a central system. So you can see it downloading here, downloading the things from Koji, creating the repository, installing the dependencies needed to run the actual tests, and then going through, and these are then the results. So there's something for basic auth, there's something for PHP, there's something for serving HTML over SSL, and whether the vhost works. And this is how it would be reported to the central result storage systems. And unfortunately, again, with the demo, I was expecting that to take longer, because that's honestly just about, yeah. That, I think, is actually just about all I have. So I guess in conclusion, pushing things upstream when it makes sense helps everybody. I'm thinking of my audience. If you're an employee at Red Hat and you have tests that would make sense to go upstream, please try to get that to happen. Not all of them can, not all of them should, but it doesn't hurt to ask, I guess. And please take advantage of the resources we have. Please come if you want to use the Beaker installation we have, if you want to learn how to use Taskotron, come find us, come find me, because the whole reason for having those things there is so people can use them. And that's what I have. Like I said, I thought the demo was going to take longer. Ralph?
Can you tell us about the diskit for Taskotron tests? What the plans are for that?
The question was if I could talk about diskit for Taskotron tasks. That is going to be our next major feature. The idea is that the diskit is the system that Fedora, and as far as I know, RHEL uses to keep track of spec files when things are built. So what our plan is to have, to make it available to all packagers for Fedora to push tests into diskit, so that whenever there is a change in Git, whenever there is a Koji build of that package, Taskotron will go in, read which things need to be run them, and then report them to the central database. And at this point, that's about all I have, because we're just getting started on the actual implementation. So I don't have the details yet, but that is the gist of what we are planning. Does that answer your question?
Well, dependencies, if the library changes, that test applications, what will that do to that library?
And the question was, what about dependencies? What happens when the dependencies of something change? That is a use case we have not gotten to yet, to be honest. It's something we just have not gotten to. I'm open to the idea, but just have not gotten there yet.
With regards to Open QA, I assume you have to maintain that library of expected result screenshots. Is that done manually, and is there a ton of overhead to that?
The question was about Open QA and whether or not, and how much overhead there was in the needles and the things that need to be maintained within Open QA. And I can only answer that from a Fedora perspective. From what I understand, the OpenSUSE folks have a different way of doing things than we do, so that they, it tends not to be as disruptive. In my opinion, stuff like that is great for smoke tests. In practice, we tend to have to redo things, if there's a new GTK build. Then things are off by a couple of pixels and all the visual comparisons fail. If there's a change in one of the fonts that's used in Anaconda, then we have to go to redo all the pictures. But in practice, that's, every couple of weeks, and it takes about a couple hours. But that's for the number of tests that we have. That's your question?
Yep.
Okay.
Any estimation how many of the major components actually perform upstream testing? I'm asking from the over community, and we hit a lot of issues on the underlying components. It's QMU, LVM, multipath, and so on. So there is some fear of using Fedora as opposed to CentOS for our upstream testing, just because we hit many bugs that we feel that the components should be tested. Do you have any estimations how many are actually tested?
The question was if I had any estimations on how many of the major components are tested as in the way I'm talking about. I don't. At this point, I think it's most of the upstreams are doing their own testing, and then things drift into Fedora. I think there's little formal things of saying it's like, okay, so in Fedora we have QEMU, we have KVM, we have those kind of things. The kernel guys do a lot of their own testing in Fedora, but as far as this idea of trying to take tests from upstream of Fedora. Or having them, whichever, I'm trying to think of the best way to phrase it. It's not very many. Certainly not as many as I would like.
That's exactly why we refrain from Fedora. We don't have a refrain policy, but we prefer CentOS at some point, which is a shame because it's exactly against what we preach.
Yeah, but I would very much like to see people use Fedora, but at a certain point, I do understand that productivity can be affected. So I would, how to phrase it? I would please use Fedora, but, and if you certainly have any ideas on what we can do, like which areas need testing, so that we can look into that, or especially if you have ideas on where we can find resources to run those things, that would certainly be appreciated. Yeah.
So is the issue that you don't want to run the over tests on Fedora because you find that Fedora becomes unstable?
Yes, we find regressions in underlying components, which waste our time on our CI.
But perhaps a solution long term would be with this new disk for tests, if we could get the over tests themselves and run them as part of the Fedora QA process, then we would know that we've produced a regression that will break the test suite before it even gets out our door to use. Does that make sense?
Yeah,
But we
we
don't have
don't
quite
have our build it.
we don't have quite such an ability to open up for arbitrary tests and other things yet, but
Yeah, that has just started in the last month or so. We finally got the features we needed in order to really accept tests from other groups went out 2 weeks ago. So it's relatively new, and I like his answer better than mine. Any other questions?
Eventually, I would like to see some differences between packages and their tests. So, first part of the question is whether test results are like machine parsable, and the second part of the question is whether this is something you are looking into, like is that something on your plan to have these differences between, for example, RPM RHEL, whether it's already integrated or not. So I would like to see more of the differences than the results themselves, because that's what I really care about, the packages, right?
So I'm going to try rephrasing your question to see, and please tell me if I've misunderstood. There are two parts, and the first question was whether or not the results from tests are machine parsable. I'm not exactly sure what you're asking, so I will try and answer, and you can let me know if I'm getting close to where you're getting at. So as far as the things that are running themselves, whether the machine parsable or not, that's completely up to the people who are writing it. But that being said, and we don't force people to report into our systems, but everything is, it's very easy to put it into what we call ResultsDB. And ResultsDB is just a RESTful interface to a database that is open for pretty much everyone to query. So if you know what you're looking for, you can say, okay, so has the RPM grill been run against the latest HTTPD? You can search. You can use the RESTful interface to search for that. Is that what you were asking?
Yeah.
Okay.
Probably going to be answer. So the test would use the format that I want, for example, JSON. So it's about the test. It's not about the results we get, right?
I'm not.
The test is responsible for the format stored into ResultsDB.
Kind of. Not really. It is responsible for making sure that ResultsDB can parse it. When the task is run, we store the artifacts from it. So if it generates like an HTML report, or if it generates some other artifact that explains what's going on, that is stored. And you can find links to that through our results storage system. But the results storage system is a single format or a single layout, and it's relatively simple on purpose, where it keeps, this is what it was run against, this is when it was run, here's a link to the logs, here's a link to the original job, and here are some notes. And that's queryable. But as far as getting it from, the output of nose or PyTest, just things that come to mind right off the top of my head, into that online database, it's a responsibility of whoever's writing the task to make sure that the translation happens. Does that answer your question? And the second half of your question was, and I'm still a little unclear, you were talking about the difference between RPMs and tests. Can you try that again?
I think I can rephrase.
Okay.
Not test for a specific version. What changed from a previous version?
Is that? That is not something we have yet. I know one of the things that I want to get done soon is using libabigail, and I think they recently released a tool, the ABI package diff. I think I'm close to that. That is one thing I'd like to see run on every package, so we have a method of finding, okay, the ABI changed and it wasn't supposed to, or run RPM grill, which is not quite what I think you're asking about. The ABI package diff, I think, is the one sounds like is closest to what you're asking about. It is not there yet. I'm hoping it will be relatively soon, but because the components are all there, as far as I know, all the features are in Taskotron, and the packages are in the Fedora repositories. It's just getting someone to sit down, either someone on my team or some volunteer to sit down and write the actual task for it and make sure it gets scheduled.
So the task would download both the packages and do the data.
Yep. And then store the results. Any other questions?
So I have a question about the disk configuration. Would this mean that only packages would be able to submit, or package would be able to submit new tests, or would there also be permission, a pipeline permission to allow others to submit tests without being able to change the spec file?
Okay. And the question was about the earlier thing about the dist-git style tasks, and whether or not, since we're putting it into the repositories used for the spec file for packages, whether it will be packagers only or only packagers who are able to do these tests, or if other people will be able to. I don't have, the way I'll answer that is, at the very least, packagers will be able to. That's going to, I think, come down to our exact implementation. That's something in the back of my mind where I think that's a reason not to put them directly into the same Git repository. So it's going to be in my mind, it's going to be a balance between making it look like it's in that repository so that maintainers and testers only have to put it in a place, so that packagers don't have to say, okay, so I've got my Git repository, and here's the different branches, here's my spec file, here are my patches, here's my sources file. And then if I want to have tests, I got to go over here and clone this other thing and then put the tests in there. I really want it to look to the packager like it is all in the same repository, but I do want to have get other people access, because it's not always just the packager who's going to be the best person to test it. So the short answer is I don't know, but I really want to have more than just the packager have access to push tests. Any other questions? Alrighty, well, with 5 minutes left, I guess that would be it. Thank you very much.
Okay, so if someone asks questions and wants a scarf, you can come by and grab some scarves.
Oh, yeah. I was answering questions, not thinking about scarves. Does anyone want a scarf? Oh, he's got one.